In this next lesson, we're starting to talk about what shortcuts, perhaps, can we take to determine that two triangles are congruent. We're starting with ASA Triangle Congruence, which is an abbreviation for angle, side, angle. So you'll notice in this first explore activity for this lesson that they're asking you to draw a segment that's 4 inches long and label the endpoints A and B, and then to use a protractor to draw a 30-degree angle, and use a protractor to draw a 40-degree angle, and so on and so forth. So I did that twice, and notice that my two triangles are exactly the same. And it says, put your triangle and a classmate's triangle beside each other. So here are my two triangles beside each other. Is there a sequence of rigid motions that maps one to the other? And what does this tell you about the triangles? Well, I could translate, in other words, I could slide this triangle and it would be exactly on top of the other one. So I could do a translation. Yes, a translation, perhaps. And what does this tell us about the triangles? The triangles are congruent. And even though we didn't deal with this angle C and we didn't make sure that AC is congruent to BC, what this activity demonstrates is that with this side being guaranteed congruent to this side and these two angles being guaranteed to be congruent, that is enough to guarantee that the triangles are congruent. So in a polygon, the side that connects the two consecutive angles is the included side of these two angles. So it's asking us to describe the triangle that we drew using the term included side, be as precise as possible. So triangle ABC has angle A, or the measure of angle A, is 30 degrees, the measure of angle B is 40 degrees, and the included side, segment AB, has length 4 inches. And based on our results, how can we decide whether two triangles are congruent without checking that all 6 pairs of corresponding sides and corresponding angles are congruent? This kind of throws back to what I was mentioning previously, that if two angles of one triangle are congruent to two angles of another triangle, and their included sides are congruent, then the triangles are congruent. In this Explore Activity 2, they're kind of going through the exact same activity and being a little bit more precise about what transformations would map one to the other. In the interest of keeping my videos as short and manageable as possible, I'm not going to go over this so that we can go over the next few examples. In Explain 1, I am asked to determine whether the triangles are congruent. Notice here they have the angle, side, angle, triangle congruence theorem, which is almost exactly what I had written back here. Okay, so if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Pretty much the same thing I said before. In example 1, we're comparing the angle measures and side lengths of this triangle and determining whether the triangles are congruent. So I have this 2.3, I have this 2.3, so I know that's congruent to this. I know this angle is 61, and I know this angle is 61, so they are congruent. And 2.3 is the included side between these two angles in triangle ABC, but 2.3 is not the included angle between these two angles. But that's okay because this 45 doesn't equal this 74. So we're going to use the triangle angle sum theorem, you see them doing that here, in order to find angle D, which is 45, so now this 2.3 is the included side between two pairs of congruent angles. And so, yes, these triangles are congruent by angle, side angle. In part B, first thing they want us to do is to find the measure of angle P. So in triangle MNP, I have these two angles. I want to find angle P, again, using the triangle angle sum theorem. So they started off with angle M plus angle N plus angle P, adding up to 180 degrees. So this is 31 that I'm substituting in, and this is 38 that I'm substituting in. And when I combine my like terms, I have 69 degrees plus the measure of angle P equals 180. So the measure of angle P will equal 111. And it says none of the angles in triangle MNP has the measure of 110. Therefore, there is not a sequence of rigid motions that would map triangle MNP onto triangle JKL, and triangle MNP is not congruent to triangle JKL. In this reflect question, it's asking us, do we need to find the measure of angle K? Well, with angle L already being obtuse, we know that angle K is not going to be obtuse. So we know that it's not going to equal angle P. So, no. When we found the measure of angle P, we knew there would be no angle in triangle JKL having measure of 111 degrees. In these your turn examples, they're asking us to determine whether the triangles are congruent. So one of the things that you want to start getting really, really familiar with is when two triangles are sharing a common side, like these two triangles are sharing this common side, I know that segment AD is congruent to segment AD because of the reflexive property. And you're going to find in the subsequent proofs that we're doing, this becomes a very important property that we use very frequently in proving that triangles are congruent. Okay? So I have that AD is congruent to AD. They told me in the diagram that BD was congruent to CD. I know that angle ADC is a right angle because it's marked as such, but that also means that angle ADB is going to be a right angle because they form a linear pair. And so, yes, triangles are congruent by angle side angle because AD is congruent to AD based on the reflexive property. This was given to me as congruent to this, and I know that angle ADB and angle ADC are right angles. And we know from a previous lesson that all right angles are congruent. In this your turn 6, I have this segment congruent to this segment, so that's one piece of information. I have that this 38-degree angle is equal to this 38-degree angle. This 67, or let me say that again, angle 1 is the included side between the 38 degrees and the 67 degrees. In order to use angle side angle, I need to find the measure of angle R. Okay, so the measure of angle R is found by taking 38 plus 72 plus the measure of angle R will equal 180 degrees. So when I add these two together, I get 110, plus the measure of angle R equals 180. So the measure of angle R is 70 degrees. And since angle R is not congruent to angle U, the triangles are not congruent. And now we're doing some more proofs. We've seen proofs before. We're now proving that triangles are congruent. So in this proof, we started by being given these two pairs of angles are congruent. So one habit that you might want to develop is taking the given information and marking it in the diagram. So I know that angle MQP is congruent to angle NPQ. I know that angle MPQ is congruent to angle NQP. And so they've written all that out in the given. And then, once again, notice that because these two triangles are sharing a common side, namely QP, I can say that QP is congruent to QP because of the reflexive property of congruence. And notice that that side is the included side between those two pairs of angles. So I can say that the triangles are congruent by angle, side, angle, triangle congruence. In part B, they've written the statements out for us, and we have to come up with the reasons. So angle A is congruent to angle C. Well, 9 times out of 10, you're going to start a proof with the given, and there it is. This is given. I am also given that E is the midpoint of segment AC, so I write that down for that reason. And then now I'm saying that AE is congruent to CE. Well, that's because E is the midpoint of segment AC. That's the definition of midpoint. Remember that the definition of a midpoint is a point that divides a segment into two congruent parts. Angle AEB congruent to angle CED. Well, that doesn't come from any of these statements, so let's look at the diagram and see why angle AEB would be congruent to angle CED. And I'd hope that after last chapter, you'd notice that those are vertical angles. And so the reason why these angles are congruent is because of the vertical angles theorem. And let me go ahead and mark this given information that I hadn't marked before. I said in this statement that AE was congruent to CE, and since those segments are the included sides between these two pairs of congruent angles, the triangles are congruent by angle, side, angle. In this Reflect Part 7, it says, in Part B, suppose the length of AB was 8.2 centimeters. Can we determine the lengths of any other segments in the figure? The answer is yes, because CPCTC says that corresponding parts of congruent triangles are congruent. So what does AB correspond to? First letter, third letter. It's going to correspond to first letter, third letter. So I know that CD will also be 8.2 centimeters. In this next proof, we're kind of on our own. They didn't give us the statements. They did give us a given. They did give us something to prove, but we are expected to kind of follow along with what we've seen in these previous proofs in order to come up with our own. Remember that 9 times out of 10, you start with the given. So I am given that angle JLM is congruent to angle KML. So that's angle JLM, that's this angle, is congruent to this angle. I'm also given that angle JML is congruent to angle KLM, and that's this smaller angle inside of it. So that's given. Again, even though these triangles are overlapping, I'd like you to notice that they are sharing a common side. They're sharing side LM. So I can say that LM is congruent to LM because of the reflexive property of congruence. And since LM is the included side between these two pairs of congruent angles, I can now prove that triangle JML is congruent to triangle KLM because of angle side angle. One more proof, and once again they've kind of left us on our own, so we start with the given. Angle S and angle U are right angles. That's given. And RV bisects segment SU. And that's given. Okay, so let's first talk about what it means for these angles to be right angles. We know that all right angles have 90-degree measure, and if angles S and U are both 90 degrees, then I can say that angle S is congruent to angle U. And that's actually a theorem that was addressed in the last module. We didn't deal with it extensively, but you are going to see that we use it quite a bit in this module when we're proving triangles congruent. And it doesn't really have a name. We just say all right angles are congruent. Okay, since we know that RV bisects SU, remember what that word bisects means. That word bisects means that it's dividing SU into two congruent parts. So what are the two congruent parts of SU? ST and UT. So I know they're congruent because of the definition of bisect. Okay, so let's take this information that we've got so far and mark it in the diagram. I know angle S and U are right angles, so I know that they're congruent. I know that ST is congruent to UT, but in order to use angle side angle, notice that that property has 3 letters. I need to know that there are 3 pieces of congruence information in a very specific order in order to say that these two triangles are congruent. So I have one pair of angles, one pair of sides, angle side angle. Well, I need one more pair of angles. And one of the things that you'll start to get more fluent about noticing in diagrams like this is these vertical angles. Remember that they are going to be congruent. So I'm going to say that angle RTS is congruent to angle VTU because of the vertical angle theorem. And so finally, I can say now that triangle RST is congruent to triangle VUT because of angle side angle.